Okay, let's go ahead and start the recording now. This recording is going to deal with another application of quadratic equations to word problems. So we want to take a look at that, see how we can work it out. In this case, this problem is on page 705, number 35. Page 705, number 35 on your book. And the problem reads that a new toy store is opening next week, and the owner is deciding how to price one of the toys. The equation S equals negative 32p squared plus 960p predicts the total sales S as a function of the toy's price P, where S and P are in dollars. What price will produce the highest total sales? Okay, so in this case, we're given this equation here. S equals to negative 32p squared plus 960p. Okay, and this function here, this equation is telling us S, which is the total sales, and P is the price of the toy, of the new toy. So think about it here, okay? If you make the price of the toy very expensive, nobody's going to buy it. So that means you're not going to make a lot of money. If you make the price very cheap, a lot of people could buy it, but you're not going to make too much money because the price is going to be very low. So you want to find out the highest price that you can price this toy and still make a lot of money with it. And what's the highest price that you can price it and make the highest amount of money? So we're talking about a high number, a high price. That hints to the vertex. Remember that quadratic equations, which this one is one quadratic equation, has a they can either have a high point or a low point, and that name is the vertex. Remember that, okay? It's a special name. In this case, this quadratic equation has a high point. Why? How do I know it has a high point? Well, remember that in here the A is negative 32 and the B is 960, and there is no C, so that means it's 0. So since the A is negative 32, that's why it's a sad face with a high point. Okay, so whenever the A is negative, you're going to get a high point. Whenever the A is positive, you get a happy face with a low point. So let's find this high point, because this high point, if you think about it, is an order pair, and it's made up of the variable P and the variable S. P and S. So this will tell us the highest price that we can price this toy and get the highest amount of money for it. Okay, so what is not the highest price, but this will tell us the highest amount of money that we can get, okay, by selling this toy at this price P. We want to find out that price. So we want to find the vertex, and there's a formula for that. Vertex is an order pair. In this case, it's made up of a P and it's made up of an S. P is the price of the toy, S the total sales. So the formula for P, in this case, the price of the toy, will be negative B over 2A, comma S. Okay, so this will give us the P coordinate, or you can call it the X coordinate of the vertex. Well, obviously remember that B is 960 and that A is negative 32. So putting that information in here, we get negative 960 over 2 times negative 32 will make negative 64, comma S. Okay, we're going to go ahead and divide negative 960 by negative 64. So let's go ahead and divide negative 960 by 64, and that will be exactly 15. Okay, so this will give us $15. So it's telling us to price our toy for $15. If our toy is $15, that will give us the highest amount of sales. Okay, and as you know, the graph of this equation will look like a the graph of this equation will look like a sad face with a high point. So if you price the toy at $15, this is what it means graphically, okay? You price the toy at $15, it will give you the high amount, it will give you the highest possible sales. Okay, so we know that we have to put the price of this toy at $15, and I wonder what is the highest amount of sales that we're going to make. Okay, well, for that, we can go ahead and put 15 on P and solve for S. Okay, so we just substitute 15 where the P is, and we work out the equation, and we solve for S. Using PEMDAS, we have 15 to the second power. That's 15 times 15, which is 225, plus 960 times 15. That's 14,400. Okay. Negative 32 times 225, that will be negative 7,200 plus 14,400. If you work this out, it will give you $7,200. Okay, this means that when your price of the toy is $15, you're going to get the highest amount of sales for that toy, and that's going to be $7,200. Okay, when the toy is $15, when the price of the toy is $15, it will give us the highest amount of sales, which is going to be $7,200. So you have to be aware of these ideas in quadratic equations that occur. Okay, so remember the vertex formula always, okay, is the x-coordinate is negative b over 2a comma y. If you find out what is the x-coordinate of the vertex, okay, you can find out what is the y-coordinate. In here we found out what was the p-coordinate, because we're using p for price, the p-coordinate of the vertex, and we were able to get 15. And after that, we were able to find out the s-coordinate of the vertex, which represents the total sales, and we found out that the total sales for the toy is $7,200. Let's go now with another application of quadratic equations. Okay, and this one, it's going to deal with finding the root. I'm not going to finish this problem with the root because we've already done several of them finding the roots, but I want to tell you how more or less the problem is. Okay, so in this problem, which if you have your book, you can go to the following page. It would be on page, let me see here, this problem is on the following page. Page 569 is problem 2. Page 569, problem 2. Okay, it's the example problem. So if you read this problem, it basically tells you that there's an athlete that he's going to throw down a shot put. Okay, so he's throwing a ball in the air. The ball's traveling. Obviously, it's going to reach a high point. And this athlete, let's say it's standing on the origin. That's the x-axis, that's the y-axis, standing somewhere here, and the ball is going to land somewhere here. Okay, the high point is that which we know is the vertex, and these are called the roots, if you remember. Okay, and there's an equation given to you in the problem, and the equation is y equals negative 0.04 x squared plus 0.84x plus 2. Okay, so from the quadratic equation you can determine your ABC. Your B is 0.84 and your C is 2. And the question is how far will the ball land from the athlete? Okay, how far will ball land from the boy? Okay, so you want to answer the question, how far will the ball land from the ball? Well, if you notice, if you find out how far it will land from the ball, that means that you're trying to figure out the root, because the root is telling you how far it is. We want to find out what is that distance, or what is this number here. That's what I want to find out, that number. Okay, so if you want to find the root, that means what? And this is an order pair, and this order pair is made up of what? An x and a y, and the root, actually the root is the x-intercept. So if you remember, I said in classes that the x-intercept, in the x-intercept, the y is always 0. And the y is always 0 on the x-intercept, and that tells you that this y here in the equation will have to be 0. Once you put 0 for this y here, because it is, and you're trying to find the root, you're trying to find x, then that gives you a hint to use the quadratic formula, because you have a trinomial that's equal to 0. So you're going to use the quadratic formula for that. And we used the quadratic formula many times before. I'm not going to do the quadratic formula here because we've used it many times before. You can look at the other videos. Well, the final answer is, remember how the quadratic formula gives you two answers, right? One answer is negative, which we discard because x is approximately negative 2.16. And the other answer is positive, which is x is approximately 23.16 feet. Okay, we don't want the negative square root because we're talking about distance, and distance relates to a positive number, positive quantity. And so the ball will land about, sorry, they use meters, they don't use feet in that problem, they use meters. Okay, ball will land approximately, ball will land approximately 23.16 meters from the athlete after he throws it. Okay, so you can look at that problem because they use the quadratic formula to find the answer. Well, that's it for quadratic formula and quadratic equations. We're going to move on now into new topics. So be on the lookout for more videos.